All right, so we are talking still mean and standard deviation and variance, okay? Today we're gonna talk about transformations though. Transformations for the mean, standard deviation, and variance. When it comes to these problems, the mean and standard deviation are typically given, all right? Or you can calculate it like you guys did from the last lesson. And now the question is, what transformations can we do? And this is both for discrete and continuous, okay? What will happen to the mean? What will happen to the standard deviation? What will happen to the variance when we do transformations like adding the same number to all the data points or multiplying the same number to all the data points? What happens to the mean? What happens to the standard deviation? What happens to the variance? All right, so that's the question we are answering today. All right, so I have 6 properties for you guys. The first ones are all about the mean. And the mean is super straightforward. Do what naturally comes to you. All right, do what naturally comes to you. All right, so property number 1. And on your notes, I have 2 columns. One is for you to write out what's happening in writing, right? So that's the words. And the other one is to write it as a formula. These are your notes, guys. You can write down whatever part is most useful for you. You can do both parts. You can just do the formula. It's up to you. All right. But basically what this is saying is if we add or subtract a constant from every single data point, right, it's going to shift the mean. So if I, for example, looking at number 1, if you go below the chart, let's say a teacher decides to give everyone extra credit points for being a cool class. Okay, 2 extra credit points. If the original average of the class is 80, well, what's the new average? All right, so what's happening is that the teacher is adding 2 points to every value in our data set. All right, so 2 is our constant. What that's going to do, according to our formula, is it's going to take the old average, that's the E of X, and also add that constant. So in this case, the original average was 80, which means our new average would be 82. All right, so I'm on example 1 at the bottom of your chart in case I lost you. All right, so that one, is pretty intuitive, I believe. Any questions though? Okay, so that one's pretty straightforward. Just do what naturally comes to you. Okay, let me make this a little bit bigger. Let's go. There we go. All right. And yes, you do have to show the work. Okay, so make sure you get used to showing at least the 80 plus the 2. You don't have to do the notation, but just the 80 plus the 2, just to show a little bit of work. Okay. All right, so that's the first property. Okay, pretty straightforward. The next one is if we multiply. If we multiply every data point by the same number, it also multiplies the mean by that same number. Okay, so again, if we multiply every value in our data set by that the same number, the new mean will be the old mean times that same number. So for example, number 2, it says the average cost of an item at H&M is $20. H&M used to be like my favorite clothing store because it was like cute, but it was like affordable. But anyway, let's say the average cost of an item is $20. For Black Friday coming up, there's a huge sale where everything is 60% off. What's the new average cost now? All right, we want to find the new average cost. So for this one, right, we have every single data point is being multiplied. It's 60% off. So that means we're paying 40% of the original price. So I have 0.40 being multiplied with every single item, right? Everybody's paying 40% of the original cost. So according to this formula, to get the new mean, I would just take that same number and multiply it with the old mean. So that's going to be 0.4 times the old mean, which was $20. And that gets me $8, which would be amazing if that was the true average price of all the clothing at H&M. $8. That's awesome. All right, any questions on that property, number 2? All right, well, let's do one more for the mean, and that is when we combine variables. All right, so this one, is saying that if I have 2 variables, right, I have 2 lists. I don't have just one list, I have 2 lists, and I decide to combine the lists and add them, right? The means would just be the sum of the means of the 2 lists. Or if I want to find the difference, then I would subtract the 2 means, and that would get me the mean of the new list. All right, so for example, number 3, it says the average salary of a teacher at SMHS is $100,000. I don't know if that's true. I'm just making that up. The average annual expenditure is $60,000. So expenditure just means how much people spend, right? So we earn $100,000 and then you can like spend $60,000. What is the average annual savings? All right. So to do the savings, well, we know that it would be E of, I'll say salary is S minus the expenditure, E, will be the savings, right? And then that would be the mean of the salaries minus the mean of the expenditures. And this was $100,000 was the average salary and $60,000 was the average expenditure. So that means the average savings for San Marino high school teachers would be $40,000. All right, you can buy a Tesla with that. Okay. And that is your last property when it comes to means. So let me take a long pause here and see if there's any questions. Put it in the chat or unmute yourself. So my advice for you guys for these first 3 properties, don't overthink it. Don't overthink it. It is as straightforward as you think. So don't overthink it, but do show work. Okay, definitely show work. All right. All right, so let's move to, this is where it gets complicated. Okay, so this is where you really need to have your mind focused right now. Why don't we divide anymore? Ooh, good question. The reason why we're not dividing is because dividing is the same thing as multiplying by a fraction. So it's just to simplify it. Yeah, like dividing by 2 is the same thing as multiplying by 1/2. So we're just going to simplify it and just call it all multiplication. Good question. All right. Okay, last 3 properties, guys. This is all about the variance. Note, variance, not standard deviation, variance. One more time, variance, okay? These properties do not apply to standard deviation, so do not try to. That is the probably number 1 mistake I've seen students do, is they'll accidentally try to do this with standard deviation and it just doesn't work. Okay, so properties for variance. Watch how weird this is. Okay, this is going to be a mind trip. All right. For variance, adding or subtracting a constant from the data doesn't change the variance. You don't have to do anything. Don't add or subtract that same constant. It actually stays exactly the same. Okay, so example number 4, going back to the teacher. Teacher decides to give everybody 2 extra credit points for being a cool class. If the original variance of the class is 5.2, what's the new variance? All right, so the setup, is the same like we did before, right? We had, all right, teachers giving extra credit to each person. So in my parenthesis, I know this is just still x plus 2, right? But I want to find the variance of that. Well, based off of this property, I do nothing. Even if everybody gets extra credit and everybody's score changes, the variance is not going to change. It's a measure of spread. So everybody shifts, measure of spread doesn't change. So my final answer there is still 5.2. I don't do anything. For some reason, that's actually the hardest thing for students to do, because it's like it goes against your natural like instincts, right? You're like, I have to change something. But in this case, you don't. You actually do not do anything. Okay, questions on this one? Okay, I see it in chat. Oh, just kidding, I don't. All right. All right, 2 more properties for variance, and I'll do another long pause in case you guys think of one. Yes, actually, person in the chat, we are going to talk about multiplication. Perfect segue. All right, so multiplication. Now, what happens when we multiply a constant? What happens to the variance is you actually square that constant and then multiply the old variance to get the new variance. Okay, so same question for number 5 as before. At H&M, average cost per item is usually $20 with a variance of $12. For Black Friday, huge sale, 60% off. So you're only paying 40% of the original price. What is the new variance? All right, so if we want to know the new variance, again, the setup in the parenthesis, still the same. We're just multiplying 0.4 times x. All right, we're taking 40% of the original cost. So to get the new variance, you do 0.4 squared, okay, I'm going to do it this way, times your old variance. All right, so that is 0.16 times $12. Yep, all right, and then that should get you 1.92. All right, and that is your new variance. Okay, so this is special for variance. When you multiply a constant, you actually have to square it. You have to square it and then multiply the old variance to get the new variance. Okay, questions on this one? Okay, looking at the chat box, nothing yet. Okay, all right, let me go one more and then I'll do a longer pause and see if you guys have any questions on our 3 properties for variance. All right, so our last one is when we combine 2 variables, okay? This one, if the variables are independent, there's like a caveat to using this property. Variables have to be independent. I'll let you guys know, I'm not going to try to trick you or anything. All right, I'm going to tell you that variables will be independent. All right, so just assume it, okay? Now here's the thing for this one. This is interesting. When you combine variables, either by adding them or subtracting them, it doesn't matter if you add or subtract. You always add the variance. You always add the variances. So notice this is plus or minus here, but here it's only plus. You always add. All right. So for example, number 6, going back to the teacher's salary, right? We're trying to find the savings. So this was, I'll just leave it as X. X is how much they make for salary. Y is, oh, actually, I'll just keep it consistent with what I had before. Sorry, changed my mind. So salary minus expenditure, that is equal to how much they save, right? But based off of this property, I actually still add the variances of the 2. All right. So the variance of the salaries was $22,500 based off of our problem. The variance of expenditure is $40,000. So So that gets us 62,500 for the variance. And ooh, this was a little tricky. It asks, what is the standard deviation? It doesn't ask for the variance, it asks for the standard deviation. So if I want to find the standard deviation of what I just found, I need to square root. How do I do a square root? Okay. Okay, maybe not. Okay, so square root the 62,500. I'll just draw it in. And that gives us $250. And I'll draw the square root. All right, so that is actually how you get to standard deviation, is you actually find the variance first, and then you square root whatever you got to find the standard deviation. Okay, that was our last property. So variance, those three, tricky. All three of them are tricky. The first one, when you add or subtract a constant, do nothing. Keep the old variance. Second one, when you multiply a constant, you have to square that constant. And the third one is always add. Okay, always just add. All right, let me take a long pause. Questions on the variance properties. All right, so examples. This is on the back of your notes. I'm going to go ahead and take out the context, right? Meaning like without any like H&M or, you know, teacher salary. Let's just straight up get the numbers, see what we do with it. All right, and use those properties. Okay, so for example, if the mean of X is 3, standard deviation of X is 2, mean of Y is 4, standard deviation of Y is 1. I want to find out what is the mean of X plus 5 and variance of X plus 5. Okay, so this tells me I'm adding 5 to the entire data set, and I want to find the new mean and the new variance. Okay, so the first thing for mean, super straightforward, right? Do what comes naturally. E of X plus 5 is just going to be E of X plus 5. So that's just 3 plus 5, which is 8. Okay, that's it. 5, and then you add it to the 3, you get an 8. Done. Okay, so mean, super straightforward. Don't overcomplicate it. The variance. All right, so the variance, this one's a little bit trickier. First off, they give me in the problem the standard deviations. So let's go ahead and find the variance, because I know that is what I need, because those are the properties. So variance would be the standard deviation square. So that is 4 for X. And the variance for Y is 1 square, which is just 1. All right, so there is that one. All right, so variance now, if I add a constant, remember, variance doesn't change. So it's just 4. Done. All right, questions on that one? Okay, let me do a few more, get you guys a little more comfortable with that. Let's try part B. All right, part B says, what is the expected value, the average, when you do 2x minus 1 in variance? Okay, so I'm doubling all the x's and I'm also subtracting 1. All right, so for this one, mean, super straightforward. 2x minus 1 will just be 2 times the mean of x minus 1. So 5. Done. All right, and yes, you can show work like this. You can go straight to the 2 times 3 minus 1. Perfect. That work is good. Okay, Variance. Here's my recommendation. There's two things happening here, right? You have the doubling of the x and you have the -1. I would handle it one at a time for now, just because, you want to make sure you're being very careful. So what I mean by that is let's handle, let's say, the -1 first. Well, if I have something -1 with the variance, I know it doesn't change anything, so I can actually ignore it. So variance of 2x minus 1 is just variance of 2x. The -1 doesn't do anything to the variance, so I can ignore it. Now using property number 5, I need to square that too, right? So this is going to be 4 times the variance of my x. So basically if I take out that 2, I need to square it. So this is 4 times the variance of x, which is 4, which gets me 16. All right, any questions there? All right, then let me go to this next one. I'm going to have you guys practice with the others. So the last one I'm going to do, number or letter C. I have x plus 2y. All right, x plus 2y. For the mean, again, do what comes naturally. X plus 2y will be x, which is 3, plus the mean of y times 2. So 2 times 4, giving me 11. All right, for variance, using these properties, again, we're assuming that these are independent already, so we can use this property. This is going to be the variance of x plus the variance of 2y. All right, always adding. All right, so I'm going to split the first. And the variance of x is 4 plus, well, if I'm doubling the y's in a variance, I have to square that 2. So I'm going to square that 2 to be 4 and then times that variance. And that gets me 8. All right, and that's my final answer for that one. Okay, questions before I have you guys try the last two on your own. If not, go ahead and do it. If you have questions, put them in the chat. I'll give you guys 3 minutes. 3 minutes, go for it. All right, guys, let me go ahead and show you how to do D and E. All right, so for the mean of 3x minus y plus 4, I'm going to basically straightforward multiply and just substitute in the means. So for x, I have a mean of 3, so 3 times 3 minus the mean of the y, which is 4, and then plus 4 gets me 9. All right, and that is the answer for the mean. Now, the variance, this is where it gets a little tricky. All right, so for the variance, first off, I know that if I have that 3 times the x, I need to square that 3. So I'm going to do 9 times the variance of x, which is 4, plus, because we always add variances, the variance of y, which is 1. And remember that plus 4 does nothing. All right. In fact, I would even recommend, if you see that, just like cross it out, pretend it's not there when it comes to those variances. All right. And that gets me 37. And to get the standard deviation, I just square root that 37. All right. So square root of 37, I believe that gets me like 6.0, let me see, 08. All right. And on the quiz, I will specify how many decimals you need. Okay, and that's it for this lesson.